These are the lesson 11.5 notes on geometric series. Today what we'll do is we'll find the sum of an infinite geometric series, the sum of a finite geometric series, and we'll evaluate summation notation problems involving infinite series as well. The other day we learned how to find the sum of an arithmetic series. We did that by calculating the number of pairs of numbers that we were adding together. We took the sum of the first and last terms and we multiplied that by the number of pairs. When you're working with a geometric series, first of all, there's a difference between having a finite number of terms and an infinite number of terms. A finite number of terms, you kind of see the beginning of the word finish here. In a finite series, there is a established set number of terms. It's going to begin and it's going to end. It's not going to go on forever. And if that's the case, this is the formula that we use for the sum. The sum of the n number of terms, n is the number of terms you're working with, equals the first term times 1 minus the constant ratio to the n power divided by 1 minus r. One thing I will note that is, although there are no parentheses typically listed when this formula is given, you really want to put this denominator in parentheses, especially if you're typing this in your calculator. For example, for this problem, we have 2 plus 6 plus 18 plus 54 plus, and this pattern is going to continue for 10 terms. To find its sum, we're going to use the formula that we just talked about. We're looking for the sum of the first 10 terms, so n is equal to 10. And this is equal to the first term, which is obviously 2, parentheses, 1 minus. Remember, to find the constant ratio, you might notice what it is here, but if you aren't sure, pick a term other than the first term and divide it by the term right before it. So take any term and divide it by the previous term. In this problem, you could take 6 divided by 2, or 18 divided by 6, or 54 divided by 18. All of these things should give you an answer of 3, and that's your r value. So in this problem, our constant ratio is 3. N again is 10. It's the same subscript that we had earlier. And this is going to be divided by 1 minus r, or 1 minus 3. If you type this in your calculator, it's very important that you put this in parentheses. When you crunch out what this is equal to, you'd actually get 59,048. And that would be the sum of the first 10 terms in this series, starting with 2 plus 6 plus 18 plus 54, and continuing multiplying the previous term by 3 until you get 10 terms. What I'd like you to do is see if you could find the sum of these terms. These would be the first 12 terms of this geometric series. Using this formula here, we'll pause the video and see what you get in just a moment. So in this problem, we're looking for the sum of the first 12 terms. We will need to calculate r, so in this problem you can take any term divided by the previous term. Now I used -2 and 1, but you could also do 4 divided by -2 or -8 divided by 4. In any case, you would get -2 for your ratio. So we're going to find the sum of the first 12 terms. That's equal to the first term, which is 1, times parentheses 1 minus the ratio, which we plug in -2 in parentheses. Whenever you're substituting a negative number, always put it in parentheses. Our exponent is 12. That's the same as the subscript. That's n. Close the parentheses off, and we divide it by parentheses 1 minus parentheses -2 parentheses parentheses. If you type this in your calculator correctly, you should get -1,365. If you're having trouble getting this value but feel like you have the formula correct, see me and we can figure out what's going on. Now, we're also going to calculate the sum of an infinite geometric series, and you might be wondering, how can you add an infinite number of numbers together and not get infinity? Well, the rationale is this. If you choose a ratio that's between -1 and 1, we can also write as the absolute value of r is less than 1. So we're dealing with numbers that are between -1 and +1, not including 1, or -1. If that's the case, an infinite series converges to a finite sum. Converges means it comes together, you will get a specific answer. However, if r is greater than or equal to 1, and I wrote it as the absolute value of r, so we're talking about values that are bigger than +1 or smaller than -1, including 1 and -1. If that's the case, an infinite series diverges and does not have a sum. Diverges means that your answer is either going to be heading out toward negative infinity, it's going to be heading out toward positive infinity, or it might be bouncing back and forth between negative and positive answers. Here's a sequence of numbers 16, 8, 4, 2, 1, etc., etc. And the question is, does this series converge or diverge? Remember, to calculate r, we take any term divided by the previous term. So I could do 8 over 16. If we do that, you get 0.5. You could also get 0.5 by doing 4 over 8, 2 over 4, or 1 over 2. 0.5 is smaller than 1. The absolute value of 0.5 is 0.5. It's less than 1, so this is a series that would converge. On the other hand, here's the same, appears to be the same group of numbers, but notice the numbers we're adding are getting bigger and bigger and bigger. In this problem, when we divide a number by its previous term, like 2 divided by 1, we get 2. In fact, any one of these problems, if you divide by its previous term, will give you 2. This number is larger than 1. We say this series would diverge. And what we'll do is we'll look at some problems here that may involve converging or diverging sequences. In the case of an infinite geometric series converging, then the formula that this sum will equal is given by the formula S equals a sub 1 over 1 minus r. This looks kind of similar to the formula we had earlier, other than the fact that it eliminates this additional factor in the numerator. Why does it eliminate it? Essentially what happens is that you end up with an r value that's small to a huge power right here. Decimals between 0 and 1 that gets raised to a power like this eventually head towards 0. This ends up being basically 1 minus 0 or 1. So this more or less just kind of cancels out. So let's use this formula and see what you get. By the way, this formula is only valid when the absolute value of r is less than 1. So you can only use this formula when r is between -1 and +1. For example, here's a series of numbers and it says plus dot dot dot. This is an infinite series. It continues on forever and ever. Notice in this problem the r value can be found by taking a number and dividing it by its previous term. If you do 5 over 10, you get 0.5. That means our series converges. And since it converges, you can use this formula. The sum is equal to a sub 1, our first term, which is 10, over 1 minus the constant ratio, which is 0.5. Again, you probably want to put the denominator inside parentheses. If you divide 10 by 0.5, you get 20. If you were to actually add 10, 5, 2.5, 1.25, we're going to be adding smaller and smaller and smaller numbers. Eventually, we're adding practically more or less 0. So this is a converging sequence, and it converges to 20. What I'd like you to do is see if you can find the solutions for these next two problems. We'll pause the video and see what you get in just a moment. For the second sequence of numbers, we're going to find what r is equal to. I took a term divided by its previous term. I did 3 over 9. That's equal to 1/3. You could also do 1 over 3 or 1/3 over 1. You get 1/3 both ways. The sum is equal to the first term, which is 9 divided by 1 minus the ratio, which is 1/3. When you crunch that out, you get 13.5. For our last series of numbers, I took 8 divided by 4 to get 2 for our ratio. You can notice that each term we can find by multiplying the previous term by 2. So using our formula, our first term is 4, and we divide it by 1 minus 2. When I crunched this out, I got -4, and I thought, that doesn't really make sense. If I'm adding 4 and 8, that's 12, plus 16 is 28, plus 32 is 60. My numbers are getting bigger and bigger. Why would I get a negative here? Well, notice if the absolute value of r is less than 1, we can use this formula. Our r value, however, is 2. It's bigger than 1, so we can't use this formula. You're not allowed to use this formula here, and it's pretty evident that the numbers we're adding are getting bigger and bigger. If there's an infinite number of these numbers, our series is basically going to head toward infinity. All I'm going to say here is that our r value is greater than 1, so the series diverges. Finally, the last thing we'll do today is evaluate infinite series written in summation notation. So we're familiar with what this looks like from the other day. What I want to do is I'd actually like to write out the first few terms so we can evaluate this series using our formula from above, but I want to know what the first few terms are. In the first example, I'm going to plug in 1 for n, so my first term is equal to 2 times 1/2 to the 1 minus 1 power. And my second term is 2 times 1/2 to the 2 minus 1 power, and my next term is 2 times 1/2 to the 3 minus 1 power, plus dot dot dot, etc. Now when I crunch this out, my exponent here is 0. So this is like 2 times 1/2 to the 0 power. And my second term is 2 times 1/2 to the first power, and my other term is 2 times 1/2 to the second power. 1/2 to the 0 power is equal to 1 times 2 is 2. So my first term here is actually equal to 2. I should have done a little equal sign. My second term is 2 times 1/2, that's equal to 1. My third term is 2 times 1/2 squared. 1/2 squared is 1/4. 1/4 times 2 is 1/2. So to find our infinite series here, we're going to use our series formula, which is equal to our first term, which is 2, divided by 1 minus the constant ratio. Here my ratio appears to be 1/2. As I go from term to term, my terms are getting smaller by a factor of 1/2. 1 minus 1/2 is 1/2, and 2 divided by 1/2 is equal to 4. This is a series that converges on 4. What I'd like you to do is I'd like you to see if you can figure out what the first 3 or 4 terms of this series is. See if you can figure out what the first term and the common ratio are in particular. Then use the formula for calculating the sum of an infinite series. Pause the video, we'll see what you get in just a moment. For our last example, what I started with is I plugged in 1 for n into our little expression here. So we have negative 1/2 to the 1 minus 1 power. Then I plugged in 2 for n and then 3 for n. Simplifying the exponent goes from 0 to 1 to 2. And when I calculate these powers, I got 1, negative 1/2, and positive 1/4. The ratio here is negative 1/2. I took the second term and divided by the first term. Negative 1/2 divided by 1 is negative 1/2. So that's our r value that goes in the denominator. Because it's negative, we put it in parentheses. Our first term is equal to 1, so our answer is 1 divided by 1 minus negative 1/2. This is actually equal to 0.6 repeating, or 2/3. And now you know how to find sums of infinite and finite geometric series.